or when we say reflection of light, what do you understand with that? I have a red mic here. What's the name again? Yeah, what's the name?
Baby.
Huh?
Baby.
Timmy, okay. I think you can very much understand. So what do you understand by reflection of light? Just give me an overview of what it is.
Reflection.
Yeah, reflection of light. And I'm sure it's something you've done before. Okay, you want to say something? Talk now, talk. If you know you say something now. You want to say something? Okay, but you've heard of the word reflection, Abby?
Yes.
Okay, and I'm sure you have used the word reflection before, maybe when you were having conversation with somebody.
Yeah.
In what context do you use it?
When the
light bounces.
Now you are talking. Why were you not talking before? Alright, so basically, reflection has to do with the deflection of light. The deflection of what?
Light.
Deflection in this context is that whenever light hits a surface, alright, it bounces back. Alright, exactly. Okay, I don't want to go into too much theory. Let me just go straight down into it. So say, for instance, we have a plane mirror, right?
Yes, sir.
What do we call this?
Incidence ray,
and the
reflected ray, and
and
that's your
that's
normal.
the normal.
Okay, good. So this is the normal ray. This is reflected ray. Is that correct? And this is a what? Incident ray. This is what? Incident ray. So what I'm just doing is I'm just giving an overview of what the topic is all about. Now, there are two laws of reflection. Are you with me?
Yes.
You
Yes,
can
sir.
see them. You know what's the first one?
The point
The
of incident.
the angle of incidence is the same as the angle of reflection.
Yeah, that's the second one. It's in two parts actually. Yeah, what's the first one?
The incidence ray, the reflected ray, and the normal, they all lie on the same
They
plane.
all lie on the what?
Same.
Exactly, beautiful. So, and it also says that the angle of refraction, or reflection, sorry, is equal to the angle of what? Incidence. Is equal to the angle of what? So that's I is equal to R. Alright, so please, these are some of the things you need to know when dealing with questions involving reflection of light waves. Okay, also another thing you need to know is the angle between the normal and the plane mirror is always what?
90 degrees.
It's always 90 degrees, exactly. So they can give you a question like this. They can give you a question like, the incidence ray or the angle of incidence is, they say the angle of incidence is, angle of incidence is, let's say, 45 degree. Or let me use 45. Let me use 45 degrees. Alright? So let's say, suppose a ray of light or a source of light, alright, points directly at a plane mirror. I'm just assuming a question now. So they can ask you, a source of light points at a plane mirror, and the angle of incidence is what? 55 degrees. They can ask you questions like, what angle does the reflected ray makes with the plane mirror? Are you with me?
Yes.
Now, this is the reflected ray. Are you with me now?
Yes, sir.
Now, the angle that the reflected ray makes with the plane mirror is not the angle of reflection. I hope you know.
Yes, sir.
It is the angle here. Alright? So this is the angle of reflection, and this is the angle the reflected ray makes with the what? Plane mirror. Makes with the what?
Plane mirror.
Exactly. So what do you do? How do you find that? If the angle of incidence is 45, how do you get this? Since you know that angle of incidence and angle of reflection are the same thing, right? So how do I get this part? So obviously the angle of incidence is 55 degrees. Am I correct?
Yeah.
Angle of reflection also will be what?
55 degrees.
Then what will be the value of this guy here?
That'll be 90 minus
Exactly. 90 minus what?
55.
Which is what? That's 35 degrees now, right?
Yes.
So what I'm just doing is I'm just picking out questions you would like me to see, alright? Okay, let's move on to something else. Let's move on into mirrors. Let's talk about mirrors. There are three kinds of mirrors now, right? We have plane mirror and we have two kinds actually. Then under two we have one. There are two kinds. We have plane mirrors and spherical mirrors. We have what?
Plane mirror and spherical.
Plane mirrors and spherical mirrors. Plane mirrors and what? Spherical mirrors. Under spherical mirrors, that's when we have concave and convex, exactly. But plane mirrors. So let's just talk about plane mirrors quickly. Now, in plane mirrors, mostly every one of us have plane mirrors now at home. The normal standing mirror you have at home. And that's what we call plane mirrors. Alright? Now let's talk about images formed in a plane mirror. Images formed where?
In a plane mirror.
Formed in a plane mirror. Now, there are two kinds of images formed in a mirror. The first type of image is what? We have a real image and we have a what? A virtual image. A real image and a what? Virtual image. You have to understand this very well because once we get into magnification, and then we'll take some practice questions on that. Now, a plane mirror always gives a virtual image. It always gives a what? It always gives a what? Now, how do you identify a virtual image? A virtual image is an image formed where? Behind the mirror. It's formed where?
Behind the mirror.
So if you are looking at a plane mirror, right, what you are looking at is a reflection of yourself. Are you with me? Now, the image you are seeing, alright, appears to be behind where? The mirror. Appears to be where? Behind the mirror. Exactly. So please take note that plane mirrors always gives a virtual image. Now, they can also ask you questions like this. They can say, supposing that we have two mirrors inclined at an angle to each other. Let's say you have two mirrors. Let's say the angle between them is let's give an example. Let's say 90 degrees. Are you with me?
Yeah.
So two mirrors are inclined at 90 degrees to each other, two plane mirrors. And then you place an object, let's say a candle, right? You place a candle in front of these two mirrors. They might ask you how many images will be formed. Do you understand the question?
Yes,
so you have two plane mirrors and then you have an object in front, right? So how many images are you going to see here?
Two.
I'm going to see two. No, you will not see two.
You see 3.
You see three, good.
Yes. The formula is 360 divided
Exactly.
Divided by
theta
theta
minus
minus
1.
one.
Beautiful.
So,
That's 360 over what?
Theta.
and that will
Minus
give you
1.
4 minus 1. That
Theta here is the angle at which you are inclined now, right?
Yes.
That's 360 over what? 19 minus 1. What do you divide by 19?
that is 4 minus 1.
That's 4 minus what? So
That's-
therefore, you see two of the candles here, and you just see one here. So these are questions you will likely come across. They can just give you instead of using 90 degree, they can change the angle. Are you with me? So okay, let's talk about magnification for a little bit. Magnification. So let's take a question, a practice question under this. First off, what is magnification? Magnification. What is magnification? Yes. Okay, when you say you magnify something, what does that mean? To enlarge it now, right?
Yes.
Exactly. Now, in the context of physics or in the context of light waves, magnification simply is the ratio of the size of an image. Size of what? Image over what? Size of what? What size of object? That's good. Magnification is the ratio of the size of an image to the size of what? An object, yes. It's the ratio of the size of an image to the size of an object. Now, most times they don't want to use size of an image, they use height of image.
Or height of.
Exactly. Height of image. But what? Height of what? Object. So height of image is normally represented with h prime, while this is just normal h. Are you with me? Now, most times if you don't want to use height of image, they can say you can use size of an image. Or let me use size of an image now. Let me use image distance, right? Over what? Over object distance, exactly. So in this case, we're not going to use image distance is represented as v. Object distance is what?
U.
Is u. So please, this implies or tells you something that image distance and height of image, they are not the same thing. Are you with me? Image distance and what? They are not the same thing, please. Alright? Then you can also have another formula. So this is also, these are formulas for magnification. So it's either you use this, or you use this, or you use this. And then I think there is one more. You can also have image distance over length of what? Camera. Image distance over what? This is another formula. Let's take a practice question and see if we can apply this. I'll apply this. So let me know when you're done. Example 1. Let's take this question. It's even a wild question. Alright, let's go. Are we good? Alright, let's go. Right. Oh, this is length of camera. Example 1, are we there?
Yes, sir.
Length of camera. Height of object distance. Yeah, let's go. Example 1. Oh, sorry, where did I seal up this? Here, the height of an image placed at a distance of 60 centimeter. The height of an image placed at a distance of what? 60 centimeter. The height of an image placed at a distance of what? Of 60 centimeter. The height of an image placed at a distance of 60 centimeter. Are we there?
Yes, sir.
From the hole of a pinhole camera. From the hole of a pinhole camera. From the hole of a pinhole camera. I'm sure you know what a pinhole camera is.
Yes.
Okay. From the hole of a what? Is
Camera.
15 centimeter. Is 15 centimeter. Is 15